Alright, here we have a classic line intersects circle problem. We have a circle which is defined by the equation x squared plus y squared minus 2x minus 3 equals 0. And here is my pathetic attempt at drawing a circle with the tablet here. And it's intersected by a line 3x plus y minus 5 equals 0. And it will be intersected at these 2 points here. So if we are to solve these two equations together simultaneously, although here we're going to solve them by the substitution method, the result, we should get two answers, two results, one being this point here and the other one being this point here, the points where the circle and the line intersect. So let's get cracking, and first of all we'll write down our circle equation: x squared plus y squared minus 2x minus 3 equals 0. And then our equation of our line: 3x plus y minus 5 equals 0. So what we're going to do here, this is the equation of the circle, equation 1, this is equation 2. So what we're going to do here is fairly classic. We will, first of all, we see we've got y here on its own, so we can manipulate this equation to get an equation for y, which we will then substitute into equation 1. So for a start, let's get the red pen out here, and let's add 5 to each side. So we can add 5 to here, and while we're at it, we could also substitute 3x from both sides. So we're adding 5 to both sides, and then here we're subtracting 3x. So what we're going to end up with there is collecting all our terms: 3x minus 3x plus y. So we're going to get y, and minus 5 plus 5 equals 0, plus 5 minus 3x. So y equals 5 minus 3x, rearranging equation 2. So now we can substitute y into equation 1. So we're going to get x squared plus 5 minus 3x all squared minus 2x minus 3 equals 0. Now we've done expanding of brackets earlier, so I'm going to not show all the steps with that. So we can just expand this out. So we get x squared plus 5 5s are 25. Okay. Minus 30x. 5 times 3x would be 15x, and that would be twice, so it's minus 30x, and that would be plus 9x x squared. So that there, just with the red pen, that there is the expansion. This here becomes this here. So square of the first minus plus twice the sum of the brackets plus the square of the last. So that there's become that, and then we're just going with the minus 2x minus 3 equals 0. So let's collect all our terms together. So we've got x squared plus 9x squared is 10x squared. Minus 30x minus 2x is minus 32x. And we've got plus 25 minus 3 is plus 22. Okay, 10x squared minus 32x plus 22 equals 0. Now just looking at that, we can reduce that down a little bit more because these are all even. So we can reduce that down by dividing by 2 into everything. 5x squared minus 16x plus 11 equals 0. If we look at the factors of 11, there's only two factors, 1 and 11. So we know that to solve our brackets, we're going to have 5x in here. We're going to have x in here. Both signs are going to be negative. So this is 1. I think we're going to have the 1 in here and the 11 in here, so that when we go minus 11x minus 5x gives us the minus 16x. So that was relatively easily solved, and so now we can start to look at this. Either for this to be 0, one of these factors or terms must be 0. So either x minus 1 equals 0, and x equals 1, or 5x minus 11 equals 0, and 5x equals 11, adding 11 to both sides, and then let's divide through by 5, and we get x equals 11 over 5. So we know our x components in both cases here. We'll just put a bracket in here. So that's going to be 1, and then the y value, and this one here is going to be 11 over 5 for the x value, comma, and then some sort of. So what we'll do here is when x equals 1, y equals, so we just go back to our equation here, 5 minus 3x, so x is 1, 5 minus 3, y equals 2. So we can see then that this the coordinate of this point up here is 2, the point 1, 2. And just moving over to here, that was the phone there. Anyway, as we were, where were we? Okay, when, so let's have a look now when x equals 11 over 5, y will equal 5 minus 3 times 11 over 5. So just to make this simple, I'll just use the red pen. 5 is actually 25 over 5, so that gives everything the same denominator, and so y would equal 3 11s, which let's just go back to the red pen here. 3 11s, I'll just put 33 up there. So we get 25 minus 33 is negative 8. Get a yellow pen here. Negative 8 over 5. So then we can fill in here again with the red pen. Negative 8 over 5. So let's just to get our answer here. There are two intersections. Two intersections. We've got one at the point 1, 2, and the other one at the point where x equals 11 over 5 and y equals negative 8 over 5, as we've got it drawn on the diagram. So there you are, solving the classic line intersects circle problem using substitution.